Hey everybody, this is Mr. Beckstrom, and today I want to take a look at an example from section 10.3. This is on the ellipse, and it says the semi-elliptical arch bridge. An arch in the shape of the upper half of an ellipse is used to support a bridge that is to span a river 14 meters wide. The center of the arch is 2 meters above the center of the river. Write an equation for the ellipse in which the x-axis coincides with the water level and the y-axis passes through the center of the arch. All right, so let's go ahead and draw this and then see what we need to do. If we go ahead and just do a graph, so if the x-axis coincides with the water level, that means it either needs to be the major axis or the minor axis, depending on whether or not this thing is stretched vertically or horizontally. So the way that we check that is um, the length that is greater is going to be the major axis. So if it's going farther horizontally, that means that we're going to use the formula for when the major axis is the x-axis. And if the vertical line is longer on this ellipse, then we're going to use the y-axis formula. That's where the y-axis is the major axis. So if we do the center right here at the bottom, and we're going to use that as the origin, if the total distance is 14, we just divide that by 2. That means we're going out 1, 2, 3, 4, 5, 6, 7. And then 1, 2, 3, 4, 5, 6, and 7. So that means that this ellipse is going to go through -7, 0 and +7, 0. And then it's also going to go up 2 to reach the top of the bridge. And then it's going to go down 2 because the ellipse is symmetric with respect to both the x-axis and the y-axis when it's centered at the origin. All right, so now we're going to kind of draw this thing, and we can pretty easily see that that the horizontal distance of this ellipse is longer than the vertical distance. Therefore, the major axis is the x-axis, and we're going to use that formula. And the formula for the ellipse with the x-axis being the major axis is going to be x squared over a squared plus y squared over b squared is equal to 1. Now, if this was the opposite, if the vertical distance was longer, then we'd simply just replace the a squared with the b squared. So it'd be x squared over b squared plus y squared over a squared. Just remember that a always, for the ellipse, a is always related to the major axis, and b is always related to the minor axis. Now, looking at this is actually going to be pretty easy because a is just the positive distance from the center to the major axis intersection, so that's just going out 7. B is just the same thing except for the vertical distance there, so going from the center to the y-intercept here, so that's just going to be 2, a distance of 2. And C, we really don't even have to know for this one. That's going to be inside where these foci are, and that just usually helps us to graph it, but we don't actually need it for the formula, so I'm not going to do it. But if we needed to, the formula for that is b squared is equal to a squared minus c squared. So if we had to find if asked to find the foci, then we would plug in b squared here, a squared there, and then solve for c squared. But we have everything that we need, so the final formula should be x squared over a squared is 49 plus y squared over 2 squared, which is 4, is equal to 1. Now, the only thing is, if for some reason my math lab didn't take it this way, I might write 49 as 7 squared, and I might write 4 as 2 squared, but I think it should take it like this. All right, if you have any questions, let me know, and I hope you have a great weekend. Thanks.